C1 sequences, proof of the formula for the sum of n terms. So we've been introduced to this formula for the sum of the n terms. So in order to prove this, I'm going to write out Sn in full. So Sn is the sum of the first n terms. So my first term of an arithmetic sequence is A. Then I'm going to add on the next term, so it's going up by a common difference each time. So the next term is going to be A plus D. And the next term is going to be A plus 2D. And then we've got A plus 3D, A plus 4D, and so on, all the way up to the nth term. If you remember the nth term, we've got is A plus n minus 1D. So that's the nth term. I'm just going to write down a term just before that, which is going to be A plus n minus 2D. And then we've got lots of terms in between. So the next step, I'm going to write this in reverse. So I'm just going to write this in reverse. So I'm going to start from the end. So I'm going to have A plus n minus 1D plus A plus n minus 2D. Then I've got A plus 2D, A plus D, and then plus A. That should be a plus A on the end. So now what I'm going to do, I'm going to add 1 and 2 together. So if I add 1 and 2 together, I've got Sn plus Sn. I'm going to get 2 Sn. And then I'm going to add each one of these pairs together. So I've got A plus n minus 1D, which gives me 2A plus n minus 1D. And I'm going to keep adding these pairs together. So I'm going to add this one onto this one, and I'm going to keep adding each one of the pairs together. So this last one, I'm going to add onto this A. And each time, I get 2A plus n minus 1D. So I keep getting 2A plus n minus 1D, and I keep adding those together, and I've got this n times. So I've started with n terms, and I've added them together to another n term. So I've got this 2A plus n minus 1D n times. So I can write this again, this 2Sn, as n multiplied by 2A plus n minus 1D. And then because I want the formula for Sn, this is 2Sn, so I can divide the entire thing by 2, so I get Sn is equal to n over 2, and then 2A plus n minus 1D.